Okay, so this is solving quadratics 2. We're going to be doing the same thing we were doing before, but now that you know the British method of factoring, you can solve some more difficult ones. So that's what we're going to be talking about today. But before I jump in, I want to talk about this up here. This is a quadratic in ABC format. That's the generic formula for that. And the reason I wanted to talk about it is a lot of times in math books, on other videos that other teachers made, they refer to things like the A term, the B term, and the C term. So this is the A term, that's the lead term. The B term is the middle term. And then the C is the end term. So when I'm doing this today, I'll talk about the A term, the B term, and the C term. So the first thing I'm going to do is I'm going to multiply the 2 times the 30. And that's going to give me 60x squared, x and 60x, 2x and 30x. C4 will work with 15, 5 and 12, and 6x and 10x. And 7, 8, 9 won't go, so it's going to be what I've got here. All right, so one thing I just wanted to point out, as this does happen, is I'm looking for a 17, and you'll see there's actually 2 pairs on here that could be a 17. And so this will lead a lot of people to ask me in class, you know, is there 2 answers to this? And there's not. There's only really one pair that's going to work, and you can kind of see right here. The only way I could get a 17 is if this was a positive 20 and this was a minus 3. Minus 3 times 20 would be a negative 60, and this is a positive 60, so I know this won't work. This one, on the other hand, I could do a 5 plus 12, and if they're both positive, they'd add to 17. And if they're both positive, 5 times 12 is 60, so I know that this one right here is going to work. So I'm ready to go ahead and start solving this now. So I'm going to write the A term here, and the C term over here. And then I'm going to substitute the B term as the sum of these 2 factors of 60x squared. Like that. So now I can factor by grouping. So on the left-hand side here, there's nothing that goes into 2 and 5, so I can divide them both by x. So I'll go ahead and take an x out, which will leave me with a 2x plus 5. I forgot that's a plus right there. Now on this one right here, 12 and 30, well, there's actually 3 factors. There's 2 will work, 3 would work, and also 6 would work. So how do I know which one it is? Well, first, you should always pick the biggest one. So I'm going to pick 6. So pull a positive 6 out. Now, a lot of times people ask me, what will happen if I pull out a 3? Well, if I used a 3, I would get a 4x plus 10, and I don't want a 4x plus 10, I want a 2x plus 5. So that's the other way you can tell, is that you know when you're done pulling something out over here that you're supposed to get this. So then that gives me my 2, oops, is equal to 0, my 2 binomials. So one of the binomials is x plus 6, and the other binomial is 2x plus 5. And so if I was factoring, I would be done, but this is an equation because it equals 0. So that means I have to solve 2 equations because of the zero products property. This times this is 0, so I know one of these is 0. So if this is equal to 0, I'll get that equation. And if this is equal to 0, I'll get that equation. So on this one, I'll just do additive inverse. And on this one, I'll get 2x plus 5 minus 5 is equal to 0 minus 5, which gives me 2x equals negative 5. And on these guys, this is how it's different than the other one is. You're going to end up getting fractions on at least one of these. Sometimes it'll even be both. Not always, but it's very, very common with these. So on that one, I get negative 5 over 2. So my solution set is negative 6, negative 5 over 2. And so that's how you do it. The only thing that's really different here from British method factoring is this part, in that you take the 2 factors and you make them into 2 equations. Now I want to look at this one down here. This is something that sometimes comes up in the context of these problems. So I'm going to go ahead and start by multiplying my A term and my C term. That's going to give me a negative 75r squared. And so if I list all the factors here, I'm going to get r and 75, 3 and 25, 4 won't work, 5 would work with 15, And I think that's it. 6, 7, 8, 9, 10, 11, 12. Yeah, none of them will work. So that's all the factors I have. Now, hopefully you could see there's a problem here. This is a 1 and a 75. That'll give me a 76 or a 74. The 3 and the 25 will give me a 28 or a 22. This one here would give me a 10 or a 20. So I can't get a 4 by adding any of these together. So what do I do? A lot of times kids will say that no solution. They don't know how to do it, and every time they don't know how to do something, they write no solution. But that's not true. There could be a solution to this. It's just all we know right now is that there is no rational solution. So if you can't solve by factoring, which is what we tried to do here, we can't do it. If you can't solve by factoring, that doesn't mean that there's no solution. What it means is there's no rational solution. It means that r could be possibly a square root. it's not a rational number like the integer -6 or the fraction -5/2. Okay? So that's all there is to solving quadratics 2.